This talk is going to be a bit more developer focused. So to just sort of reintroduce myself again, I think a lot of you just saw my last one, but my name is Wade Lewis. I'm an immersive technology applications engineer with APL's XRCC team, or XR Collaboration Center. I've worked on a ton of different projects here at APL, everything ranging from undersea to at sea to in space to medical triage. And I love just finding ways to have bring the human-centered component into XR. How do we just optimize things for the operator, the warfighter, et cetera, understand their pain points and really bring that in and kind of highlight that in XR. So this talk today, just as a little bit of a precursor, it's going to be a little bit developer heavy, but the idea here is talking about this observer design pattern. And to be completely honest, this has changed the way that I do development. We're going to be talking about Unity development, and I'm going to show a decent amount of code, but bear with me because it's really more about the examples and how we implement this than the actual code itself. So to get started, we're just going to cover some shorthand features that we see in C++. These are things that I'm going to use, and when building this, I was like, you know, these are things that we don't really talk about a lot, but it'd be great to showcase these because I find that they just make my life a lot easier when I'm programming. So the first one is the lambda operator, and we'll see this one pop up a bunch, but basically you have some parameters and an expression at the end. The key is that equals and the greater than sign to create kind of like an arrow. And basically, I have two examples here. One is the is-even function like you would normally see it, but you can also use the lambda operator to shorten this or shrink it into one line so that, you know, it's, in this case, this is a very basic example, but we're taking that and just kind of having it automatically take that int num parameter and pass that in so that we can kind of clean this up just a little bit. So then we have the ternary operator. This is one that you know, you all may have seen before, but again, another way to sort of shrink things down. It's the exact same as a regular if statement, but instead what we're doing is we're taking that is-even function and just saying the result of that, if it's true, then you know, end up returning the even string, and if it's false, then return the odd string. We also have the null conditional operator. This is a great one just to kind of check yourself sometimes, especially with null checks. It can be really frustrating to be like, oh, that's right, I have to add in a whole if statement, indent all of my code, just to say, like, is this one thing not equal to null? And especially working with game engines, whether that's Unreal or Unity, things can just kind of happen to be null sometimes. They can get destroyed or just like disappear, and it can be very nice to and helpful to make sure that you're just kind of double checking the things that you're doing and passing in, like using something like this operator. And then finally, this is one we're going to see a lot. It's called method chaining, where basically you can take one line of code but have a bunch of different methods do something to that code. So in this case, we have the C++, or sorry, C# string builder, and we have a result. But what we're doing is, and I've kind of broken it down into 3 lines, so it's a little bit easier to see there. We have 2 append statements and then a toString. So the string builder works kind of like a list. We have the first entry in the list is hello, the second entry in the list is world, and then the toString operator converts all of that into one big string and then outputs that to the string result variable. We'll see this in a little bit more. So let's talk about design patterns, because ultimately this is what we are here for today. So before we actually get into the observer design pattern, the first one I want to introduce is the singleton pattern. So the singleton pattern, the idea is you have a class that has a static instance of itself. There's only one instance of that, and the idea is that, like, it's only ever going to exist once. You normally want to do a little bit more null checking than I have here on the left side, but basically we're saying we have a public static instance called game manager, and in the awake method in Unity, so when it first starts up, we're just going to assign that to the static instance. Now what that allows us to do is anywhere in our code, and we don't even need to create a reference or do anything like that. You may have seen things like serialized fields, or if you have public fields in the Unity inspector, you can kind of drag and drop them. But now what we can do is say anywhere in our code, we just have this game manager dot instance, and anything that's public on that, you can access it. Now, I will say, like, slight caveat to this, you don't want to do this for every single piece of code in your entire project. It's going to get crazy. But for very important places, it's great to implement singletons. Now, the next one I want to introduce is the observer pattern. So the observer pattern establishes a one-to-many relationship or dependency between various objects in your project. The idea is that the things that are listening or subscribed, so you have a bunch of objects that are listening to one, in this case the cube manager, any changes that the cube manager decides to sort of push out, it'll happen to all of the objects that are listening to that cube manager. So in this case we have two methods. We have a subscribe and unsubscribe method. The subscribe method basically takes in a cube and adds it to a list. And the unsubscribe method removes that cube and from the list. And I have two different ways that we can use the remove, either remove or remove all. And we're also using the lambda operator in here, if we can throw that in as well. But on the right side, this is our cube script. And basically when it starts up, we're using the lambda operator to just kind of shrink this a little bit to make it easier to read. But the idea is that when the script starts, we're going to subscribe to the cube manager, and we already have the reference there, so we don't have to worry about it, but you could use the singleton here to kind of very easily create that reference. And then if it's destroyed, maybe the player character like runs into the cube and we actually just tell Unity to destroy it, the onDestroy method is going to be automatically called and it'll unsubscribe and remove it from the list, so we don't even have to worry about it. Now, why is this important? Well, so I talked about the cube manager can kind of like push out updates or changes and everything else will be affected. So in this case, in the update method for the cube manager, we just kind of iterate through that list and we say what we want to do for every single cube that we know of that has subscribed. We then rotate the cubes. And so the cubes themselves, they don't know when things are supposed to happen. They only know what they're supposed to do. So the cubes just know, hey, if rotate cube is called, I just need to move myself half a degree every single frame is basically what's happening on there. And so if we were to go into the Unity editor and press play, we would see these cubes are rotating, and every single cube that we have is going to do that, no matter how many cubes that we have that are listening. So we can now increase this and have a bunch of different objects in our scene that are all working off of one line of code. And we don't have to set this up. We don't have to say, okay, now every single time we create a new cube, let's drag it into the list and create another reference. Every single time, you just add them, which means that we could just instantiate these based off of code and create 50 cubes, and it all kind of just works. They subscribe themselves and unsubscribe themselves, so we don't have to deal with it. And so how can we kind of move forward with this? What I just showed on the previous slide here, actually this is the more traditional form of the observer pattern. If you go and you look this up, they're going to say to do something similar to this. But Unity has this amazing thing called the Unity events. And events are not specific to Unity, but because Unity is like extremely object-oriented, we tend to also have these amazing Unity events that we can serialize in the inspector, which basically, when we say serialize, it actually shows up in the inspector window. And on the left side there, we have basically this custom event that shows up. You've probably seen this before, especially with like UI components and things. They'll tend to have like an on-click event or something that you can drop things into. So here's actually the code that makes that work. On the left side, we have a serialized field instead of making it public, just to make it show up in the inspector. And then if you want to add something to it, so instead of populating it in the inspector, to add something to the event, you can say custom event.addListener, and some method from anywhere that, if it knows of that event, you can have it just like listen to it. So when you say custom event.invoke, any of the code, when you want to do something, any of the code in that some method will run every single time that this custom event.evoke line is run. So what are the advantages of using events? Why are we here to talk about them? Well, what we can do with events is just define them in awake or start. So when our game starts up, we tend to move all of the logic out of these update statements and into our awake or start methods. So why does that help? Well, for one thing, performance, but also we can only run the logic when the events themselves are invoked. So basically everything says, hey, I want, like it sort of sets itself up and says, I want to listen to these methods when on the very first frame of the experience, and after that, the game just sits there until we finally say, all right, now do my thing, go update our event. And so we've created this, again, this one-to-many relationship where you have a bunch of different objects that are listening to this event, and as soon as the event happens, then it can go. And so the alternative to using something like this, and this is how, if you've ever looked up like Unity documentation and said like, how do I make a mouse button click or some kind of input? Usually what they say to do is you have some kind of state, in this case I just called it my Boolean, and every single frame you have to say, is that state true, is that state true, is that state true? Finally it's true and you can do some code. The problem is that that's fine for a small project, small scripts, but as soon as you have multiple developers, it scales, this just doesn't really work because now you have these massive update statements and you have to sit through and go, okay, well, from this update statement, let me dive down into the code and figure out where we're checking the state, and it gets really complicated. So going a little bit, we're going to dive a little bit deeper into events and say, well, how do these work? So we're going to talk about actions. So action is a delegate type in C# that represents a method. That is the official definition. However, think of it as basically you can take the method and actually assign it to an action. So in this case, see how we have custom action equals some method. And so now what you can do is anytime if you say custom action, I think it's .invoke as well, you can invoke that method. Now I'm also talking about this shorthand operator, and I love this one. I use it all the time because it makes things a bit easier. Instead of having to break your do something code out into a whole separate method and create like a minimum of 4 lines, you can actually just define it all in one place where you use an open close parenthesis and the lambda operator and then curly brackets to put your code in there. So this could be just like, hey, print the string, do something. That exists in both of these spots, and when we invoke this action, it'll do the same thing. So expanding on this just a little bit more, when we bring this into the context of Unity events, this is basically the exact same slide that I showed before, except this time we've switched it to talk about events. We're saying custom event.addListener, and we pass in the method because the event takes in an action. So instead of assigning it, we're actually just passing it into that addListener method. But we could also do that same shorthand operator where we have the open close parenthesis, the lambda operator, and the curly brackets all inside of that. It gets a little crazy at first, but now what we can do is in 3 lines or 4 lines or so, we're just kind of saying like, hey, I don't really need a whole method just to execute this 1 line of code. We can just sort of pass it in there and do this little shorthand. So how does this all fit together? We're going to do a really quick example. It's like 2 slides, but this is like the most code heavy part of the whole presentation, so bear with me. The first piece that we're going to do is create a game manager. We talked about this before. We're going back to that singleton of we have our game manager instance, and on the game manager we're creating a public Unity event called onRotateCubes. Generally with events we'll start with the word on just to kind of make our, it's a little, something that we do just to, like a naming convention, just to be like, hey, this is an event. And so we've called this event onRotateCubes, and it shows up in the inspector like that. But you can notice that the list is empty. Nothing is assigned to it. And that's because the game manager doesn't really need to know how to run anything. It doesn't need to know what's listening to it, and we don't have to assign anything in the Unity inspector because we're going to do it all in code. So in the UI buttons script here, you can see we have this button called RotateCubes, and on the actual built-in Unity button component, I mentioned this earlier, there's an event on there called onClick. And so what we're going to do is we've defined a method here where basically we have 1 line of code again where we do that game manager .instance. We can throw in a null check operator to say, hey, just make sure that the game manager exists in our scene. If it doesn't, then don't run this code. And so we don't need a whole if statement just to check all of this. We just throw that in there, 1 little character. It's a very easy way to make sure that we're doing this. Then we say onRotateCubes.invoke. So basically, what this does is any time that we click the button, the event is going to run. Now, when we get into the cube manager, what we're going to do this time, so we have the same subscribe and unsubscribe. And let's see if I highlighted. Nope, I didn't highlight. Now I've broken it. All right, so we have added a start and a RotateCubes method. So in this time on start, what we're doing is we're just saying, hey, that event that we created in the game manager, we want to add a listener to it. And in this case, we have a RotateCubes method that, just like we saw before, it iterates through the list and it tells the cubes that we want to rotate. But we talked about all of this happens one time. It doesn't happen every single frame. So before, when we talked about rotating the cubes, we had to say, actually, how much of a degree do you want to turn every single frame? And we have to do a little bit of math. Instead, what we can leverage is something like doTween, where it's a library that allows you to very quickly have objects tween or basically animate. And so over on the cube class, we're doing the same thing that we had before, the subscribe and unsubscribe, but then the rotate cubes or rotate tween method that we have there basically has one line of code that says, hey, this cube, I want you to rotate. In this case, we're passing in just 180 degrees on the y-axis and do that over a period of 1 second. And so we've set up all of this code to do something extremely simple as just rotate cubes. And this looks like a very basic thing. But where do we go with this, right? Because what does this mean? Well, what exactly have we created? In this case, we have code that has completely uncoupled it from the things that are unrelated. There's no like what we call spaghetti code or spaghetti references of like things going all over the place. What we've done is we've said the logic relative to each object only exists on that object. So we have the game manager, that's sort of our just like root object that has, it makes it easy to access everything else. We have our UI that only knows about what it's supposed to trigger. So when we click the button, something happens. The UI doesn't know what it's supposed to do. We're not telling the UI that, hey, the cubes need to rotate. It just makes the thing happen. The cube manager is responsible for all of the cubes of saying, hey, we're actually going to work through that little higher piece of like when that event happens, we want to rotate the cubes. The cube manager is not rotating the cubes are rotating themselves. And so they have the logic of how do they need to move, but they don't know when things are going to happen. So all of this coming together, there's one little piece, which is we're still dependent on that singleton of the game managers just to kind of connect all of our references. But other than that, what this is really good for is additive scene loading. So for those of you that might not be familiar with additive scene loading in Unity, you normally, and especially when starting out, it's not always apparent that you can actually use multiple scenes at once. And so in the hierarchy that I have there on the right, what we have is a scene that has our camera, the light for whatever, for the entire scene, and the game manager. But then we have a separate scene for the UI and a separate scene for the cubes. But all of these connect. And the thing is that you could not have the UI or not have the cubes, and you're not going to get any errors other than, obviously your code's not going to run because you can't click the button if the UI isn't there. But now what we can do, and where this is really good and where we've used this at APL, is if I'm working on something, and shout out to Ben over here who's talking next, and he's working on the art for the lighting, I can be working on how do these cubes need to rotate while he's working on the lighting in that more game scene. And so now we can have multiple developers who are collaborating on different scenes. We can avoid merge conflicts, and everything's set up where we don't actually have to change any code in order to do this. So let's expand on this a little bit more and talk about reactive programming in Unity. Now, UniRX is an open source library that enables the .NET reactive extensions, but specifically for Unity. So why do we care about reactive programming? You all have probably heard of something like React, popular in web-based applications, but in Unity, we can think about all of the things that happen in the game loop. So start, update, awake, on collision, enter, when we have colliders hit each other, all sorts of things like that, or input data from sensors or controllers, such as maybe hand tracking or button presses on VR controllers. All of those are events. And actually, little piece that I probably should have added on here, the new input system in Unity is very event-based rather than the old input system does everything in the update loop. So the idea here is that we can take all of these events and think about it as a reactive sequence of events. And so what does this look like? Well, I also have a definition of reactive programming on here, but the best way to think of this is we have a stream of events. So this image here is a timeline, and each one of those circles is when the event happens. We don't care what time it happened or what frame it happened on, unless we want that for our code. But the important part is the event happened at a point in time, and what do we want to do? And so this is actually what we usually call a marble diagram, just kind of saying like we have some some click event that happened. So let's just say like a mouse click or something. It looks like maybe there was a double click in there in the middle, and then we got another one, which is that blue one at the end. They're also giving examples of like, maybe this is an error, but then at the very end, we're also saying at some point in time, we've also stopped and said we're not listening anymore. And so that's what that little black line is there. So the observable class is what we use in UniRX to start to handle these streams. And what does this look like stepping a little bit forward? So observable.everyUpdate is the same exact thing as calling the update loop in a regular script. The idea, though, is you can define this in start, and you can handle it in some different ways. So we have the subscribe method that is very, very similar to that add listener. So we talked about the Unity events where we're passing in code and we can add or listen to that. So that subscribe works the same way, but you can also use the lambda operator to get some parameters in there. So right now I have a little underscore that's in front of the lambda operator. If we made that, let's just call it, like if we called that frame, you can actually get the number of the frame or it might be the time, I don't exactly remember. I believe it's like a long type. But basically you can get some information about that frame of when it's happening. And these exist, they've built this into Unity so that you can do that for things like fixed update, late update, whatever. But you can also do a bunch of other things like observable.interval. And so we have two of them on here, observable.interval and timer. One example is, let's say you have some code that you need to update. Actually, this past weekend, I was working on a visualization that had about 900 different objects in the scene set up as using the observer pattern where we had one manager and 900 different objects in the scene. But what happened was updating those 900 objects 60 times a second completely tanked my frame rate. And so I was like, well, how do I slow this down? Well, let me just create an interval where now instead of updating the object's position every single frame 1/60th of a second, what if I just do that every 10th of a second? So I just put 0.1 in there. Or maybe we just need to update the position of those every 1 second. And so now what we're doing is our game logic is not so heavily dependent on the actual like frames themselves or how like the frame rate. We can slow down that update to only execute the logic like every once in a while. And then we can use timer to say, basically, after 30 seconds, run some code. Normally, you'd have to create like a whole coroutine and do this whole like, let's count down and figure out how much time is left. This is just, hey, 30 seconds, go. Execute that code when we're done. Makes it super easy. You can also hook these into Unity events as well. I figured I'd throw this in here. So we can turn the events into observable streams. So you go from that typical Unity event class to an observable stream. Bear with me, I promise it'll make sense in a second. So, when do we want to use UniRX? We've talked about how it sort of integrates into Unity, but UniRX is really, really good for asynchronous functions or sequences of events, or things that are time-based. We've already talked about the interval or the timer, but it's also really good for things where we're handling user interactions, and this is where I primarily used it. So this is an example from the documentation about how could we, in 2 lines of code, write a timer that works on a double click. But I actually wanted to make a different example. So instead of explaining this one, we're going to dive into a little bit more finally bringing this back to XR and saying we have, let's say, hand tracking or controllers. And when the user pinches the index and the thumb, we want to detect that and execute an event. So normally what you'd have to do is, and let's say that we were actually doing the math to say the distance between the thumb and the index finger, we want to calculate that, and when it's inside of a certain threshold, we turn that is pinching to true. So we're actually, every single frame, we're calculating the position of the 2 joints, and finally when you're pinching, we know that state is true. So we've got this boolean called is pinching, and let's just say for the sake of this example, it's updating when we are actually pinching. But we have that every single frame. And so we can turn this into an observable and say we're calling it the current pinch observable. And every single update, it goes through and selects that is pinching value, but we're turning it into an observable so that we get a timeline like this. So this is every single frame, what is that value of the Boolean? So for 4 frames, it's false, and then finally on the 5th frame there, it turns to true. But this is nice. We've started to define what this is, but we're still stuck in update. What we really care about is that change from false to true. because that's where we want to execute our event or our code to say, okay, when this thing happens, when we first pinch, now we want to maybe like execute, like make a noise or something like that. So how can we do that? Well, we want to create two new observables. So we're going to call onPinchStart and onPinchEnd. So either from false to true when we start or from true to false when we end, so the fingers separate. We can do that in 3 lines of code here. And for the sake of this example, I'm not going to go into it too deeply. But again, we're talking 2 lines of code to create these very complex events that are dealing with how things are changing over a period of frames. And then finally, the last thing we have to do is say onPinchStart. So when you do that, subscribe some code. We're actually even taking in a value to say we've set up our observable so that every single one of these, rather than including the state, because you can include data in every single one of these, the points there on the stream of basically stream of events. And so now what we've done is we've actually changed it a little bit to include a float of what frame did that pinch happen on. And so finally, all we're doing in this example is saying, hey, print out a statement that said the pinch started on what frame. And we've defined this in several lines of code that now we have these events where anywhere in our code, say that we use a singleton, we can very quickly say, hey, I have some code that needs to run when we first started that pinch, and I also need to know what frame it happened on, and we can very quickly get that. And so ultimately, I wanted to just finally kind of end this on a challenge statement, just like the last one, and say, how might you use the observer pattern in your projects? I know this might have been like information overload, but this is something that has completely changed the way that I think through how do I design my Unity projects, how do I link things together, how do I collaborate with other people, and it's really enabled me to push past the how do I set up my Unity project and really think about how do I solve the problems and get to that piece where I can work on the hard, complex stuff in a relatively quick period. So with that, we have a couple more minutes, and I can take like 1 or 2 questions, and that is everything. Yeah?
Do you have a good way of debugging or tracking, let's say, like a chain of events? So if one event is called another event that triggers another event that triggers another event, and so on and so forth, kind of like a call stack.
Yeah. It depends on how you where those are set up. Sometimes it's as easy to just kind of say like, hey, print out like when certain events are called, and kind of understanding. A lot of times I guess I usually look at the order in which things are called. I guess that could be, there's a number of different answers for that question. And then as you move into the like using UniRX, you could have things every single time that the pinch start happens, you could have that kind of debug or wherever you need to print that out. So you can have that go every single time, or you could populate that into a list and understand, I guess there's a lot of different ways that you can do that, but I would say usually I kind of gather information, understand when things happen in relation to each other, and then go from there. Yeah? Yeah.
So one of the issues we have is that we're constantly defining new user interactions, and we kind of have a state machine, and it breaks easily.
Mm-hmm.
You start having new things like, oh, I have flight on, which requires this button, and then
Mm-hmm.
someone wants to use sort of the similar thing for
Yep.
pinching. Is this type of pattern going to help with that?
I recently used UniRX to define two-handed interactions. So basically, like when you grab an object, and only when you press both of the grab buttons, then you can scale it. But if you only use one button, then you can actually use it to move the object around. And so yes and no. I mean, it depends on how you implement. But yeah, it's usually checking the state between certain things, and then you can use UniRX to say hey, when both of those states are true, or when the button is down on both, then do your thing. And so we at times it sort of gets a little complicated with some of the harder reactive stuff, but then once it's implemented, you're yeah, just kind of do the thing and run the code. So I'm going to go with a strong maybe, but I would like to think so, because I've had that working where you have multiple states between different objects, and even though I did it with 2, there's no reason why you couldn't have hey, if 5 of these things are true, and only when 5 or when 4 of the 5 are true, then do a thing, or execute your event that then makes that code run. And what's really powerful is interactions or that piece of like, hey, is this true or not? It's completely separate from the thing that you actually need to go, which is like your user interface that says that that value is true. And so then you don't have like all of this weird code. You can kind of say, hey, the person, the mastermind who put all these interactions together, they work on that. And on the other side, it's just, hey, like when my code needs to run, it does a thing, and that's it. So yeah. With that, I'm going to turn it over to Ben. We'll do another 30-second break or so, and then Ben Smith is going to take over.